This is Arithmetic Rules with sig figs. First off, adding and subtracting numbers. You're going to look at the number of decimal places, and you're going to round to the least number of decimal places you have. So, for example, in subtracting these two numbers from each other, notice that this has 3 decimal places, but this only has 2 decimal places. So once you get your answer, we're going to round to the least number of decimal places, which in this case is 2. So if we round this number to 2 decimal places, you would count 1, 2. You round here, and it's going to stay as a 6. So this would be 1.36. Now please don't confuse decimal places with sig figs. If you're going to count sig figs, it would be 1, 2, but we're only looking at the decimal places when we're adding or subtracting. This number, you add them together, you've got a number that says 5 sig figs, 3 decimal places, but you can't keep them all because this number only had 1 decimal place. So in rounding this to 1 decimal, you're going to find the first one. In this case, it's a 4. And this 2 means that it stays as a 4, so this is 17.4. It's just easiest to think of when you line these up. You want to cut off whatever's extra based upon the lowest decimal. So you're only going to look at as few decimal places as you have. So let's try these on your own. Here we have 5.128 plus 3.3. That's going to give us 8.428. However, we only have 1 decimal place in this number. So if we round to 1 decimal, look 1, this will be 8.4. Moving on to this number, 6.53 minus 3 gives us 3.53. However, what's the least number of decimals between these two? This 3 has 0 decimal places. So if we round this to 0 decimal places, we're going to round here. A whole number would have 0 decimal places. Based upon this 5, we're going to round this 3 up to a 4. Notice that this kind of result, rounding 3.53 all the way up to 4, just goes to show you that you want to use instruments that have as many increments as possible so that you can have numbers with more decimal places so you don't have to technically round to whole numbers where you could have a decimal. So whereas adding and subtracting dealt with decimal places, multiplying and dividing are going to count sig figs. This is because you can't line up the multiplication and division problems like you can the adding and subtracting. So in multiplying and dividing a number and then rounding, you want to round to the least number of sig figs. The least number of sig figs. So for this first one, 5.8 times 3.12 gives us 18 point all these numbers. Now don't write this number on your paper because some of those numbers have no meaning based upon the rules of sig figs. So looking at the two numbers involved, this has 2 sig figs, this has 3. So in rounding to the least, we're going to count 2 sig figs, meaning the 1 and the 8, and then we stop there, and the 0 means that it stays as an 8, so 18. Even though we have these numbers here, based upon the accuracy and precision of our measuring devices, we can only be sure of these 2 sig figs. Anything else is going to be technically incorrect. For number 2, we get a number less than 1 with lots of digits after it. You don't want to include all of these, so using sig figs. This has 4. You might initially say that this has 4, but this 0 is leading, so it is not significant. So this number only has 1, 2, 3 sig figs. So we're going to round to 3 sig figs. Once again, leading, so we ignore it. We would count 1, 2, 3, and there's a 1 after this 3, so it's going to stay as a 3, 0.363. So doing some math on your own, 3.36 times 5 gives you 16.8. Least number of sig figs is 1. 1 sig fig, which means we have to round this digit. Based on the 6, this goes up. But you wouldn't round 16.8 down to 2. We have to keep the place of this 6, and we're going to do that with a 0. So 16.8, rounding it to 1 sig fig, would give you 20. For the next problem, 8.654 divided by 1.2 gives us 7.21166, and looks like these are repeating, so I'll just ignore that. However, since we divided by 1.2, we only have 2 sig figs anyway, so we're going to count 1, 2, and get 7.2. Now I give you lots of practice. 2.50 plus 3.783. So it's best to write the non-rounded number first, just so you can see what you got. 6.283. Now remember, since this is adding, we're going to look at the decimal places, not the sig figs. This only has 2 decimals, so our answer can only be 2 decimals. So we're going to count the 2 and the 8, ignore the 3, so this really equals 6.28. Next one, 540 divided by 6.152 equals 87.7763, yada yada yada. However, 540 only has 2 sig figs. This is trailing, no decimal, so we want to count 1, 2. We're going to round the 7. Based upon this, it'll go up, so this will be 88. Moving on, 0.00271 times 3 equals 0.00813. However, we only want 1 sig fig. All of these zeros are leading, so they're not significant. So we can only look at this, and based upon the 1, we'll keep it as an 8. So this is 0.008. 15.9 minus 7.833 is 8.067, but we only want 1 decimal place, so we look here, and the 6 means it rounds up, so this is 8.1. Number 5, 2.6 divided by 10.34. That's going to give us 0.25145, etc. But we only want to keep 2 sig figs since we're dividing. So we count 1, 2. This 0 is leading, so it's not significant. So just 0.25. And finally, 49,000 times 3.65 gives us 178,850. But we only want 2 sig figs. These are trailing with no decimal. So to make this 2 sig figs, we count 1, 2. we want to round the 7. So we keep the 1, round the 7 up to an 8. Now you cannot get rid of these because you can't round 178,000 down to 18. So to keep the place of these, we're going to use zeros. So it's going to be 180,000. However many places to the left of the decimal you have before you round has to be how many you have after you round. And that concludes arithmetic with sig figs. Adding or subtracting, you're going to use the least number of decimal places. Multiplying and dividing, you're going to use least number of sig figs.